another video on the binomial expansion. This is the fourth video, and I'm your presenter, Aaron Lewis. So another topic outline for us. So we are focused on the binomial expansion in these series of videos, and in the first lesson we use combinations and factorials. In lesson 2 we applied the binomial expansion to some basic questions, and in the previous video we looked at applying the binomial expansion to some more difficult problems. And in this video we're calculating coefficients and indices. And in the next video we'll be applying the binomial expansion to some exam questions. So in this lesson we're calculating coefficients and indices. Now we're going to focus on coefficients and using the choose button. So you might need to go revisit video 1 where we looked at combinations and we looked at factorials, which we'll be using today as well. In this lesson we're going to learn about how to calculate coefficients, find the index of a binomial expansion, and finding an unknown term of a binomial expansion where we know the index. Again, this will include your knowledge of factorials, both numerically and algebraically. This lesson is suitable for A-level students, and the language of this lesson is English. And this should take around 30 minutes. So here we go, today's lesson. I would like you to know how to calculate coefficients, how to find the index of a binomial expansion, and to be able to calculate an unknown term of a binomial expansion where the index is unknown. So, using combinations, here we go. So far, in the previous videos, we've looked at what the factorial button is. So a quick refresh. 7 factorial is 7 multiplied by 6, multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. Which is great. We've also looked at n factorial, which was a quick bit of revision. N multiplied by n minus 1, multiplied by n minus 2, etc. all the way down to 3 multiplied by 2 multiplied by 1. And we did the same thing in the previous videos when we looked at what n minus 3 factorial might look like. So my rule was you start with whatever it says here, and you subtract 1 every time. So that's going to be n minus 4, n minus 5, etc. all the way down to 3 multiplied by 2 multiplied by 1. So that is a very quick tour of using factorials. If you can't remember how to do that, go back to video 1, watch it very quickly again, and go, oh yes, it's that. So I'm just going to clear my writing, and we're just going to look. So in the formula book, you are given the binomial expansion, and then next to it, there is something that looks like this. That. So it shows us what n choose r is. It then tells us the other way of writing it, and then it gives us a formula for it. So that's what we're going to focus on today. And we're going to try and get some results out. So in the previous videos, you might have noticed that 5 choose 1 kept coming out as 5. 6 choose 1 keeps coming out as 6, etc. You might have kept finding that. But can we prove it? Well, let's have a look. Okay, let's try and get a general way of writing n choose 1. So all I'm going to do in here is follow in this formula. You can see I've got n is the same as n, but my r here is equal to 1. So effectively r is equal to 1. So the numerator is going to be n factorial. The denominator is going to be r factorial, so that's 1 factorial, divided by multiplied down there, n minus 1 factorial. Well, what does that become? Well, n factorial is n factorial. In fact, let me just write that out. N minus 1, n minus 2, etc. all the way down to, just going to rub that out a second. You know what's coming. 3 multiplied by 2 multiplied by 1. And the denominator then, let's have a look. Well, 1 factorial is just 1. So it's just one lot of something. So it's going to be one lot of n minus 1 factorial. And what does n minus 1 factorial look like? N minus 1, n minus 2, etc. And if you remember from the previous videos, we can just cancel those off. And we are left with n. So that result is probably worth remembering. That n choose 1 is equal to n. And there it is proved to you. Now the other one which is worth looking at is what n choose 2 is. I'm going to follow the same approach. The numerator is going to be n factorial. And the denominator, r is 2 this time, is going to be 2 factorial multiplied by n minus 2 factorial. So I'm not going to change what I did in the previous example. Here we go. N factorial is n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3. You can see the pattern. I just need to put in 3 dots there. Okay, multiply, but 1 second, not rub that out there. Oops, there we go. Need to put in 3 dots just to show the pattern continues. You can't just write 3 times 2 times 1. Okay, so what's the denominator going to be? Well, 2 factorial is just 2. So it's going to be 2 lots of. Now, n minus 2 factorial is n minus 2, n minus 3, etc. all the way down to 3 times 2 times 1. And if you remember from the previous videos, you can just cancel off these bits here because these are being multiplied. And we're left with n minus 1 over 2. And again, that result is probably worth knowing or remembering or being able to derive. It only takes a couple of seconds to derive, a couple of minutes once you're used to it. And remember, that is given to you. The original formula is given to you in the formula booklet. So as long as you know how to manipulate factorials, you should be fine. So in today's video, we are focusing on this formula and this formula, which is the n choose 2 formula. So let's have a look. Here is my examples. I haven't got the words there. Not sure where they've gone. There we go. So calculate 5 choose 2, fully justifying your answer. So in this case here, I can't go for any shortcuts. I must prove it from sort of first principle. So I'm going to be using the formula in the formula book, which was n choose r was equal to n factorial, r factorial, n minus r factorial. Now we know what we could do. It's from the previous example. Just fly backwards. I could just dive in and use this formula, but because it's asked me to fully justify my answer, I need to do everything from beginning. So here we go. So I'm going to write it ever so slightly differently. I'm just going to change my pen colour a second. And my pen, let's go for that blue there. There we go. So 5 choose 2 is equal to 5 factorial divided by 2 factorial. 5 minus 2 factorial. So this becomes 5 factorial divided by 2 factorial multiplied by 3 factorial, because 5 minus 2 is 3. So this looks like the examples from the first video now. 5 times 4 times 3 times 2 times 1. That's going to be 2 times 1 multiplied by 3 times 2 times 1. So I'm just going to look for anything which lines up. That bit there, including that 3. And I end up with 20 over 2, which gives me 10. And they're fully proved from first principles. There's your question on the right. Have a go now. Pause the video and unpause when you're ready to mark it. Okay, so here is the answer. And there we go. I've put in the extra step there in case anybody wants it. And that's me basically showing that 3 times 2 there is the same as that 6. If you spotted that, well done. If you didn't, don't worry about it. And there you go. So mark that, check it, and then move forward. Okay, here's the next one. Find the value of n such that n choose 2 is equal to 66. So we're not asked to fully just start from first principles here. We can use the formula straight away. So we know that n choose 2 from the previous video. Hopefully you've written it down in your notes. It was n minus 1 divided by 2. So that's what I'm going to do now. I'm going to replace this n choose 2 bit here for 66. So n minus 1 divided by 2 is equal to 66. And now we're going to solve this. Multiply through by 2. So n multiplied by n minus 1. 66 times 2 is 132. How do you solve something like that? Well, we need to have a look first. So let's expand the bracket. So it looks like it's going to be a quadratic. And quadratics are nicer to solve if they're equal to 0. Now at this point here, you can either factorise or grab your calculator if you've got an equation solver on there. So I think it's n minus 12 and n plus 11. So n is equal to 12 or n is equal to minus 11. Now in this case here, although it's not strictly in this question, we have got the value of n, but because we're using a binomial, this is going to be using a binomial question, we know that n is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. So we would take this answer. But this question isn't strictly asking for it. So there are 2 answers. But if this was in context in a binomial question, 12 would be our power. Here's your example. Pause the video and have a go now. Okay, so hopefully you've had a go at this question. And you've used the formula of n choose 1. Really, really easy. Is equal to n. So there's basically no maths to do there when it appears. There we go. You see I've written it multiple times up there, but never mind. Just going to rub that out and look for you. No, it won't let me. Okay, right. So anyway, it turns out it was 88. So really, really nice question. This skill here is brilliant if it's practiced. The one on the left there, it's a really good skill to practice. Okay, so what I'd like to do is have a go at mini quiz 1, pause the video, do the quiz, mark it, etc. And I'll see you in the next example. Okay, let's move forward then. Let's do some more difficult questions. This time we're trying to find the index of a binomial expansion. So what we could do is guess the values of n. We could do that. But that won't help us. It won't develop us mathematically. So here we go. We know that I'm going to do both ways of doing this one. So if we were going to do this, we would have 1 to the power of n. That'll be my first term. My second term would be n choose 1. 1 to the power of n minus 1. This is me just using the normal binomial formula. Multiplied by 5x. And then I would have n choose 2 multiplied by n minus 2, 5x, all squared. So that's what it looked like on the previous video. Now remember, n here is a positive whole number. So that answer to that one there is going to be 1, because 1 raised to anything is going to be 1. The next thing here then, n choose 1 is n. And what is 1 to the n minus 1? Well, let's take n as 10, for example. 10 take away 1 is 9, and 1 to the 9 is still 1, so that just becomes 1 there. Multiplied by 5x, so n times 5x, which is the same as writing 5n x. It doesn't matter that it's an n, we're just going to write it down. This next one here, n choose 2. Well, we know from earlier, n choose 2 is n minus 1 over 2. This term here becomes 1 multiplied by 5x all squared times 25x squared. So that becomes 25 n minus 1 over 2 lots of x squared. Now I didn't need to do that, but what I'm going to do is I will use that on some of the next few questions, but at least you've seen it now. So all we're going to do now is just compare. So we know that the first term is 1. I'm just going to write it underneath. So that matches up, that's great. And the second term we've got is 5nx. And then the third term we've got 25 n minus 1 over 2. Now this term here, I'm not going to use that in this question, I'll use it in a later question. But I am going to use this one here. So looking, just comparing these two for a second up here, we've got 25x is equal to 5nx. Now we're not going to say we're dividing through by x, it won't make any sense. We're going to compare coefficients. We're going to compare the number in front of x. So 25 is equal to 5n, and therefore n is equal to 5. Now that looks like a long way of going around it. We could have just guessed the value of n, but the skills we're going to build from that little bit there are going to be so important in the next few examples. Here's your question. Pause the video and have a go now. Okay, so hopefully you had a go. Hopefully you followed my example. You didn't need to do the second term. It's a little bit harder to work with. Hopefully you just use the first term. Here is the answer. So I've done the second term properly, but you could have just used the 4n bit. So you've probably done it this way here, which is in my little bubble. Nice and easy way of doing that one. Okay, here we go. So this time here, we've made this one a little bit more difficult. There are a couple of ways of doing this one. We've got two unknowns this time. You might have spotted already what to do. Doesn't matter if you haven't. So if I was doing this as normal, I've got 3 to the power of n is equal to, we don't know, that's just going to be 3 to the n. The next term, and I only need to do 2 terms because it just says ax, is going to be n choose 1, 3 to the n minus 1, multiplied by 2x. Now you can see the problem here is that this is a bit of a mess to work with because I don't know what 3 to the power of n minus 1 is. With 1 it was dead easy because 1 to anything is still 1. 3 is not the case. So what do you end up with? Well, let's just take stock. Let's just take a second just to step back. Can you spot it? Well, let's just have a look. Let's just compare this term here with the 729. So 3 to the n is equal to 729. Now, if you've studied logarithms already, you will know how to solve that. If you haven't, you can pretty much get this from guessing because we know n has to be a positive whole number. So you're just raising 3 to powers and literally guessing. I know there is a proper way of solving it, but that depends whether you've studied logarithms or not. Usually, it's not covered before, but it doesn't really matter. So I've gone for 3 to the power of 5, which is 243. So 3 to the power of 6, n is equal to 6. Okay, I just haven't got a. So once we know n is 6, how is that going to help us? Well, this second term here, then let's stop writing n and let's start writing 6. 6 choose 1, 3 to the 5 multiplied by 2x. So in my calculator is going to go 6 choose 1. 6 choose 1 is 6. I already know that. 6 multiplied by 3 to the 5 multiplied by 2x. So after all that, we end up with 6 times 3 to the 5 multiplied by 2 comes out as 2,916x. So just to round off my answers, A is equal to 2,916 and N is equal to 6. And there you go. pause the video and have a go at this next question. Okay, so hopefully you've had a go at this question and done it in the same way I have. It's pretty nice to do. And there you go. So once you've found out the value of n, you can then substitute it into that second term and then work from there. So n is 5 and a is 9,375. Okay, so we're going to make this more difficult now. So this time, we're given 1 plus 3x to the n plus ax plus 189x squared. Now let's just compare this with the previous example. Let's play the game of what's the same, what's the different. What's the same? It's still a binomial. Still got an unknown power of n. We've got an unknown power of value of a there. And on the previous examples, we knew this first term here. So let's have a look. The problem with this one is the first term is going to be 1 to the power of n, which is always 1. So we can't just reverse engineer this one like the previous example. And we also know the second term is going to be n choose 1, and we're going to end up with n equals a. What we need to focus on is this second term here, because we know that numerically. So let's write that down. So the third term, the x squared term. So what's it going to be? So if we're looking at the second term, we'd write n choose 1, 1 to the power of n minus 1 multiplied by 3x. In fact, let's work these out. So 1 to the power of n is always going to be 1. This next term here, well, n choose 1, let's just write this down up here, look. N choose 1 was equal to n from earlier in the video. And n choose 2, let's get the revision up here, is n minus 1 over 2. Let's just use those now. So let's have a look. So n choose 1 is n. Multiplied by, 1 to the power of n minus 1 is still going to be 1, multiplied by 3x. So that turns out was 3nx. Now that 3nx is going to be equal to a. I've got two unknowns, but only one equation. So that's very difficult to get the answer there. But what about the second term? N choose 2. 1 to the n minus 2. 3x squared. What does that come out as? Well, n choose 2 is n minus 1 over 2. 1 to the n minus 2 is still going to be 1. And then 3x all squared is going to be 9x squared. So if I just multiply this, so imagine that's 9x squared over 1, multiply the numerators, multiply the denominators, I end up with 9. n minus 1 over 2. It would be an x squared, but I'm going to make that equal to 189. Just have a look. Where did that come from? Hopefully you spotted it, look. It's the 189 up there. So how am I going to solve something like that? Now, it's like the previous examples that from earlier in the video. I might run out of space here, so I might need to rub some stuff out. So let's multiply through by 2. 9 n minus 1 is equal to 189 times 2. 378. At this point here, we know n's going to be a whole number, so it's probably going to be quite easy to work with. I'm going to try and divide through by 9 now. So I'm just going to put in a dotted line there so I can just work on this right-hand side. Let's divide through by 9. Divide both sides by 9, which means n minus 1 is equal to 42. Expand the bracket. Equate to 0. Now you can use either you can factorize or you can use a calculator to solve it. I think n comes out as 7 or n comes out as minus 6. I'm just going to double check that on my calculator. I'm fairly sure it's right. Yep, 7 and minus 6. Now we know with a binomial, n has to be a positive whole number. So in this case, this one is invalid. So we know n is 7. Great. Can we get A? So I'm going to have to squeeze up in this box here. Now, if you're writing this out, make sure you're spreading yours out better than I am. So we know n is 7. So this term here is 3nx. So that's 3 times 7 times x, which is 21x. So therefore, A equals 21. Okay, hopefully like that. It's quite a neat little question to do, really, rather than just sat there guessing at the values. See how much harder this one is, because you can't just guess at the values of n, and that's because there's a 1 sat at the front. Here's your example. Pause the video and have a go now.